Number 3 says to sketch the graph of the function e raised to the x for the following values on the same axis. Okay, so for this, we can make a quick use of sketching graphs using the app called Symbolab. All right. And we go to Symbolab. You can just, let me start from scratch. You can just go to a new tab. Okay, just try Symbolab. Symbol come from symbol. Mathematics converting words to symbols. And AB called Symbolab. And then here it pops up. You go to graphing. Okay. Because you can do lots of things and we're going to be using it in the future for different calculations. And you can graph. So we want different values of A. Back to our question, where A is 3 and A is a third. Okay, so we want for A to be 3 and A to be a third. So we have 3 raised to the power of x. So here you have a classical exponential function. As you can see, the graph does not touch the x-axis. It comes very close, and that's what you call an asymptote. Okay, we can actually label this later down. The x, let me put the x, let's say the x, put it as -5 to -5 to let's say 6, for example, -5 to 6, and the y, let us put it as -5, for example, also -5 to 6 also. Let's see what happens. Yes. Okay, and we can click this, and here you have a sketch of A to the x, and this here is 1, 0, 1. We'll come to, analyze this why the exponential always passes through 0, 1. Okay, when the base is there clear by itself. And here Symbolab gives you another opportunity to superimpose another graph on the same axis. So we want one for a third, 1/3. Okay, 1/3. If you just put 1/3, what it will do, 1/3 is a horizontal line. There it is, 1/3. There is 1/3. 1/3 is a third. Okay, but what we want is 1/3. Okay, so what it does now, we have to put the 1/3 in here and raised to the x. Okay, so that's what it does. It 1/3 is like inverse, if you want to put it that way, or the reverse. Okay, because we have to talk about logarithms in a while. So as you can see, this is the behavior of the 1/3 of a third, and this is the 1/3. Okay, because remember 1/3 is a decimal, and it has the kind of opposite behavior to the 3. Okay, because a decimal, the more you power a decimal, the smaller it becomes. Okay, the more you power a decimal, the smaller it becomes. 0.5 raised to the 1 is 0.5. 0.5 raised to the 2 is 0.25, which is smaller than 0.5. The higher the power, the decimal decreases. 0.5 raised to the power of 3 is 0.125. So for decimals, when the power increases, the value decreases. Okay, that is the behavior of powering decimals. 0.5 raised to the power of 4, you're going to get a smaller number than the previous ones we calculated. You're going to get 0.0625. And by the way, it would have been an interesting time to start with 0. Okay, instead of starting with 1, let us start with 0. 0.5 raised to the power of 0 is 1. Any value raised to the power of 0 is 1. This is why both the 3 raised to the x and the third raised to the x, they both pass through 0, 1, because any value raised to the power of 0, any base raised to the power of 0 is actually 1. And this can be proven, a very simple proof. Okay, so that's why both pass through 1. So, but when your base is a value which is greater than 1, for example, 3, the power will increase. So you can see now for the third, the graph decreases. Bear in mind, this is the behavior of the vertical labeling decreases, but the 3 to the x increases as the power increases. Okay, so you can use Symbolab to and what you can do now is basically use snipping tool. Everybody should have snipping tool on their Microsoft. You just go to new and let us shift this out a bit, and we just from there we want there to there, and we can just, well, all right, we can. Okay, let's make it even out. So let's go to -3 and 3. -3 and 3. So it will look symmetric. And just go to your document that you are doing your assignment. You can put in a text box for maneuverability. But when you paste it, it will be pasted as an image, and it might be difficult to move around as you wish at will. You know, images have a type of permanency to them. But if you paste it in a text box, then you can shift it up and down where you want to position it. And the labeling now, let's make the line invisible, no color. Let's make the field no color. Okay, and we need to label the two graphs. One is go to fractions. I'm using math equation. Okay, so one is a third raised to the x. Okay, but you can even put y is equal to, okay, y is equal to, right click, format, no color. Right, so as I'm doing that, you can be doing this too with number 3. But you can write, but you can also practice using Microsoft, because this skill can serve you well in the future. All right, you may have to do your degree, your bachelor's degree online, and you might have to type your solutions. Okay, so now it might be a good time to practice. Okay, and this is y. Okay, so one is raised to the 3 raised to the x. It increases as the x value increases because the base is 3. 3 to the power of 0 is 1. But 3 to the power of 1 is 3. 3 to the power of 9 of 3 is 9. Of 2 is 9. Okay. 3 to the power of 3 is 27. So with 3, remember the x now, let's put an x there. Let's put an x. right there. Okay, independent variable, as it increases, the y variable increases. Always bear in mind the line that you see on a graph shows you the behavior of the y axis, the y variable. Okay, the y variable. This line that you see, okay, you see that pink line there? See what that pink line is going up? And going up from the curve, it shows you the behavior of the y variable. The x is always increasing from left to right. The x is always increasing from left to right. Anytime you just look at a graph, the x is always increasing from left to right. That is constant, that is universal. You can go China, Japan, Alaska, Australia, St. Lucia, anywhere. You look at a graph, the x is always increasing from left to right. The line that you see, the curve that you see, the zigzag, whatever, shows you the behavior of the y variable. So this is what the y is doing for this graph. It is increasing exponentially, okay, because the base is 3. This violet one now, the y is decreasing. See how the line decreasing the curve? Is the y that is increasing because the base is a 3rd. And whenever you increase the exponent of a decimal base, the value, the y value, decreases. Okay, so bear that in mind. So that's the purpose for that question.